So hi, I'm ILYA from EASYNET. This presentation is made together with Robert Trashchuk, who is author of one of the extensions present in this presentation. So let's move on. So basically, quite a lot of you probably running route reflectors on your network. So hands up who runs route reflectors. Okay, good. So that's relevant talk. So currently, if you have route reflectors and they are not on the path of the traffic, you have quite few problems associated with what kind of path you are sending to route reflector clients. So if you have a route reflector located in some location which is not sharing the same view of the network or the same best path as your router sending traffic, you have few mechanisms today to help you, like add path, but that would be not always solution, as I will demonstrate in use case scenarios. Then in some cases you can't actually deploy route reflectors in a way which would be economical or would provide sufficient best path for sufficient number of your routers. So that's another kind of problem what these proposed extensions are trying to deal with. And you also cannot deal with some type of network failures. The route reflector would not even react if you have some linked link failures on your network. And finally, sometimes the metrics what you have configured in your IGP, you can't configure them in such a way that traffic to all destinations within your network would go the way you want it. And if you start tweaking IGP metrics, you might be tweaking too much. So you just change one metric with your intention being to change traffic only to a particular destination, but in reality you are changing a lot more. So there is also a proposed solution for that. So let's start with first extension, which is optimal route reflection. So this has been presented already at IETF, and you can get more detailed information what's been proposed in the draft linked here. So what it does, currently route reflector would send exactly the same best path to all clients. And it doesn't really matter if those clients share the idea of what best is, or if they have different ideas about best path. So there's no really way to do some per client best path. The optimal route reflection lifts this limitation and allows you to send different path to different clients despite being still the very same route reflector. It requires very little change in the implementation of BGP, and it doesn't require any change in protocol itself. So this is quite trivial, and I know that some vendors already have expressed interest and maybe already secretly working on it, so they won't tell it in public. And so what extension does, it allows you to consider topological information from the client perspective and make your best path selection based on that information. For example, if you have several clients at different locations, you can have a look in your IGP database and find out what is actually cost for this client towards particular exits, and you can send one best path towards one client and the different best path to a different client. Or you might decide that, okay, I don't want to look in my IGP, I just want to administratively configure a preference. For example, if you have, let's say, a router in north of, let's say, in north of US, and you have nearest internet exchange somewhere in south of Canada. For political reasons, you might be willing to send traffic to exchange still within US, even it will be more far than nearest Canadian exchange. So that's one example. In Europe, probably could find also similar examples, like if you have peerings in Switzerland. Some companies would prefer if you keep Swiss data within Switzerland unless it has to leave the country. So, and that's where you can opt for using administrative metrics instead of IGP. Or you can even come up with your own needs. You can define your own metrics, I don't know, based on some sophisticated formulas, I don't know, on traffic levels, anything. So, and as I said, it doesn't require any protocol modification. So the packets exchanged on the network between BGP speakers are exactly the same as today. So there is no change in the protocol. There is only change in implementation of what we're actually sending. So, and this draft has been adopted as a working group document in IDR. So it's already one step forward. People have expressed support. And let's have a look at the use cases. So imagine you have quite large number of small POPs. So each POP will have maybe just 2-3 routers, and you have something like, I don't know, anywhere between 10 to 100 such POPs. So let's say at several locations you peer with network A, or you receive network A from the peers at several locations. So now you have a choice of either implementing full mesh among your routers in order to find out what is actually my best exit for each of these POPs. Or you would have to deploy a really large number of route reflectors in order to provide each router with the best, with the optimum path. So if anyone sees how you could deploy less than, I don't know, less than 3 route reflectors when you have 50 or maybe 100 such small POPs, and please let me know. But so far I haven't found a solution for that. So, and that's where optimum route reflection helps. So how? So we can place route reflector basically anywhere. Since we are not limited, we are not required any longer to send exactly the same path to all clients. We can lift cost information from IGP and see, for example, that let's say router 2 and router 7, they would like to send traffic to network A. The route reflector looks in the IGP database and sees that from router 2 perspective, exit via router 20 is the nearest. So it sends the towards router 2, it will send Next-Hop being as coming from router 20. And it will also look that from router 7 perspective, the best exit, the nearest exit would be via router 5. So it will send different best path towards the router 7. So we still haven't modified protocol in any way. It's still exactly the same update message, all the same attributes, just different information we're sending per client. Where previously you would send exactly the same to everyone, now you can differentiate who gets what. So the second is quite interesting and probably relevant to much wider number of networks. So this is probably quite common scenario how you implement route reflectors today. You have route reflector which is not on the path of the traffic, and let's say router 2 needs to send traffic to network A. First we consider normal scenario, all the links up, and the nearest exit would be over the router 1. So far so good. Now if the link between 1 and 2 fails, then route reflector being connected to both of them still sends best path as being via router 1, which is of course now no longer true, because quite a lot of you probably running MPLS, and so the traffic to the exit will be actually tunneled. So in this case, if the link breaks, the router 2 will go on the sightseeing tour all around your network and will send traffic towards network A still via router 1, but it would have to traverse links if these metrics reflect latency. Then rather than using 15, reaching your network in 15 milliseconds, it will take you, what is it, 25, it's 60 milliseconds, so it's 4 times. So customers probably not going to be very happy about that. So how we solve it? And you can't actually solve this with add path, because with add path, okay, you can send two best routes. But then in this scenario, the second best would be actually via 3, which is not much better than being via router 1. Of course, you can opt for 3. In this scenario would work. But in your network, how do you know that actually 3 is enough? Maybe you need 4, maybe you need 5. So with optimum route reflection, Route-Reflector can have a look in the IGP database and notice that 2 actually no longer can reach router 1 in 1 millisecond, but has to go over a very long path. And in fact, the 4 is actually now much closer. So instead of sending previously exit via router 1, it now sends that for you, the best path is actually over router 4. So, and you can actually combine it with add path and some additional logic. So instead of sending backup as being via router 3, which would be naturally if you have unmodified route reflection, but notice if the link between 1 and 2 fails, then effectively your backup path is useless because you cannot actually reach it in an efficient way. So, but with optimized route reflection, you can send a path which is not necessarily dictated by traditional rules. So you can, for example, start looking into shared risk groups and start sending path which is different from traditional best path. So now, this is quite interesting use case. So let's say you have a network with many POPs and you would like to place route reflector. You might have really many POPs, like maybe 30, 50. So what you can do with optimized route reflection, you can place your route reflector in a virtual machine in a data center. And because it has access to all the IGP information, it can calculate path for any client as virtually being present at that POP. So even if if the data center is located on a different continent, you can still see your cost for example, for routers, for PE routers connected to 4 and 3. You can calculate it based on the metrics, what they have to reach particular exit points, and for the different POP, you can use completely different exit. So on the right-hand side, you can see here kind of prototype configuration what could have been on the route reflector. So you just create like, or you have virtual, imagine you have virtual link between yourself and router 1 and 2 in case you're talking to PEs connected to those routers, and you have different virtual links when you are talking to routers connected to 4 and 3. Does it make sense? So, okay. So this is second extension, and this is actually modification or really extension to the protocol in the sense that we do add something what didn't exist in the packets before. So this is new address family, or more precisely, it's SAFI, not AFI, and it works to extend what has been previously done with optimized route reflections. It goes a step further. So instead of lifting information about the cost to exit from IGP, you can actually use BGP itself to send information about your cost, or particular router can send information about cost to particular Next-Hop. You can do you might find it useful where you need to use policy-based exit selection, or for example on the internet exchange points, if you're appearing with a root server. I will show you one use case which is quite common today, which would explain where this Next-Hop SAFI would make sense. So we don't introduce any new attributes. Instead, we just create new network layer reachability encoding for existing attribute 14. So this is what attribute 14 is today, and we are not going to change anything. So what we do to encode next hop cost is just using, so if you see network address of the next hop, we set it to ourselves, to all zeros. And in the last field, network layer, we set next hop is the next hop about which I'm telling you. So if I need to, if my cost to exit 1 is, I don't know, 25, and then I'm just sending next hop 1 and then cost 25. So of course 1 and 2, they will be either IPv4 or IPv6 addresses. Just checking with the time, still have a little bit. And we also can encode, this is quite interesting part. We can encode that particular next hop is inaccessible anymore. This is where it becomes useful for root server applications. So policy-based exit selection. Imagine following topology. And some people at layer 9, so the politicians have decided that the route, all traffic from router 5 to network A has to go via router 1. And from router 6, it has to go via router 2. Suppose you cannot modify IGP cost because this would lead, for example, steering too much traffic, more than you intend, to wrong direction. So, and this is how we solve it. We create Next-Hop SAFI sessions. So like today you create IPv4 unicast, IPv4 labeled unicast sessions. This is just a normal session to the peer. And you send information, I can reach router 1 with a cost 1 and router 2 with cost 2. But now the R6 is sending information about the same next hops, but it actually reverses the cost information. So from if Route-Reflector would pick up stuff from IGP, it would not see this because IGP would contain information like R1 and R2 are equally far away from both R5 and R6. So suppose all links cost is 1. So, and now, based on this next hop cost information, the Route-Reflector can make decision that R5 is getting best path via R1 and the R6 is getting best path via R2. So, and this is finally what's probably more interesting for much more people here. So let's say we have some internet exchange and in simple form you have two switches, or maybe you have more switches, but just for purpose of this discussion just simplified layer 2 topology. And you have root server connected to both of these switches. Then you have some exchange participants connected to one switch and some connected to another one. So suppose sorry, the RR and 1, 2, it's supposed to be just R1. So it's not route reflectors, they're just ordinary routers. Your typical eBGP speakers at the internet exchange, they are not route reflectors. So let's say R1 and R2 announce network A, and with all the attributes up to router ID being equal, root server decides, okay, R1 is the best exit because everything else is equal. I have to choose one. So it has chosen R1 as the best. It sends it to both R3. Oh, on the right-hand side, supposed to be R4. Really sorry for that. So these two, they are different routers. Sorry. So and then next moment, a link between two switches breaks. So now the router at the bottom right corner has best path to network A over R1, and it cannot reach it because there is layer 2 failure between two switches. So it still has possible exit via R2, but it wouldn't know about it because the root server hasn't sent this information. So this is where Next-Hop SAFI would help. So you have exactly the same failure, but rather than exchanging only IPv4 unicast prefixes, the bottom left and bottom right routers, they also exchange cost to the Next-Hop information, so Next-Hop SAFI with root server. And at the time of the failure, right-hand side router sends, oh, I cannot actually reach R1 anymore. And the left-hand side router sends, I cannot reach R2 anymore. What this results in is root server will now have information that it's pointless to send best path via R1 to right-hand side router because it couldn't use it anyway. So even if R2 is not the very best, I can still send it to bottom right router and it will be happy because at least it will be able to send traffic. Make sense? So these technologies, as I said, they are not yet available. It's really quite early stage. They were discussed since last 2 years at BGP working group at IDR in IETF, and there was some interest among people. The purpose of this presentation is to gauge interest among different audience. So if you find it useful what has been presented here, talk to your vendors and see if they would be willing to introduce this stuff to their platforms. More people talk to vendors, more chances this stuff will be implemented. So if you have any comments, suggestions, can ask here now or can email. So thank you very much.
So I've got 2 questions, very quickly. Could you move back to slide 21? So looking at that diagram, you have potentially, if there's an update to one of the NH SAFIs in the corner, one update message could regenerate the entire routing table. Could flush it again from
the information you sent in Next-Hop SAFI is actually extremely small. So let's say you have a network consisting of 500 routers. And then you have only maybe connection to 2-3 internet exchange points and you have one upstream. So all you need to send is actually information about these 2-3 Next-Hops which connect you to exchange points and one which connects you to upstream. So basically your information in Next-Hop SAFI will be something like maybe 10 routes, even for big network.
Yes, but just with the flicking one update, you could potentially be flooding the whole routing table all over again.
Yes,
yeah.
Because it might actually make sense, because if you're sending an update, it's probably because you no longer consider information what you have received from the Route-Reflector as being the best one or as suitable for a given moment. So yes, if it takes to update the whole table, yes. The other thing is, even if the update would be for the whole table, if you combine this technology with add path, you actually can converge even before. So how long it takes for BGP to converge will become irrelevant. Since you have sent previously best and the next best, or best external, for example, you sent new information about the cost, but you converge, so you start sending traffic over the new Next-Hop even before you get reply from the Route-Reflector. So it will not become more chatty than today. So how often would you have topology change in your network? Hopefully not very often. So if your IGP is very chatty today, then it's probably a good idea to fix it. So, and if your IGP is stable and you see only periodic SPFs, then this will not result in much traffic.
Okay, yeah, that answers my question. Thank you.
Thank you.
Okay, any other questions for Ilya? Thank you. Oh, wait a minute. One more.
Sorry. Just a quick one. Have you considered anything similar to MPLS route distinguisher?
Oh, but this is not actually relevant to RD. We are not talking about specific route you are sending. If you choose, for example, to use different RD for different PEs, you will be sending information about the exit points. You are not describing which exit point is actually better.
That would be the IGP.
Yes, but if you have route, let's say, have a look at this picture. If you have Route-Reflector, which is connected topologically differently from your PE, it would have no slightest idea that path from you, or even better on this picture, on this picture, the route, let's say you are sending different RD from 1, 3, and 4. But Route-Reflector would not even care if the link between 1 and 2 fails. So yes, you have all the 3 of them, but you are sending actually quite a lot. So for VPN, yes, you might solve, but not everybody is actually doing this, and there are some side effects of using different RD for different PEs. So in some situations, it might actually be better to use RD per, let's say, certain policy and not per PE. So, but this is primarily touched at global table. So, where you don't really, you could still use add path and achieve a similar effect. But as I have shown before, if you have like maybe 10 exits, how many paths do you really want to send 4 million routes? Probably not.
Thank you.
Thank you.